Hi students, this is Sivakumar, 10th standard mathematics, chapter number 3, exercise 3.19 in new edition. Okay, here we are going to discuss about multiplication of matrices. Look at that. To multiply two matrices, the number of columns in the first matrix must be equal to the number of rows in the second matrix. Look at the example. We have two matrices. First one of order 3 rows 3 columns, 3 by 3 matrix. Second matrix of order 3 rows 2 columns, that is a 3 by 2 matrix. Look at that. Here the first 3 represents number of rows and the second 3 represents number of columns. Like that, in second matrix the first 3 represents number of rows and that number 2 represents number of columns. These two must be equal, then only the matrix multiplication is possible. That means number of columns of the first matrix must be equal to number of rows of the second matrix. The resultant matrix of order is 3 rows 2 columns. What is given? These numbers determine the order of the product matrix. Now we can get into that exercise in old edition 3.18, in new edition 3.19. Find the order of the product matrix AB. Totally 5 subdivisions are there. We can do one by one. Right? Order of A given, order of B given. You are asked to find out the matrix AB. Order of the matrix AB. To find the order of the product matrix AB. First subdivision. Order of A, that is equal to 3 cross 3, that is 3 rows 3 columns. The order of B, that is equal to 3 cross 3, that is 3 rows 3 columns. You have to find the order of AB. To find the order of AB, first you have to write that matrix order A, then order of B. Look at that. Number of columns of the first matrix is equal to number of rows of the second matrix. Since these two are equal, the resultant matrix AB of order 3 rows 3 columns. Which one is left out here? 3, there 3. So 3 by 3 matrix. That is the order of AB. For the second subdivision, number of columns of the first matrix is equal to number of rows of the second matrix B. The resultant matrix AB of order 4 rows 2 columns, 4 by 2 matrix. Next one, number of columns of the first matrix is equal to number of rows of the second matrix B. The resultant matrix, the order of AB, that is equal to, which one is left out here? 4, that 2, 4 by 2. Next one, number of columns of the first matrix is equal to number of rows of the second matrix B. Therefore, the resultant matrix AB, whose order is 4 rows 1 column, 4 by 1. Next, order of A, that is equal to 1 by 1, order of B, that is equal to 1 by 3. So here number of columns of the first matrix A is equal to number of rows of the second matrix B. Since these two are equal, AB is possible, whose order is 1 row 3 column. So 1 by 3. Problem number 1 is completed. I'll be teaching the next problem in the next video. Thank you, children.